In Chapter 18, we continue our discussion on quadratic equations. We first saw quadratic equations in Chapter 14 when we learned about solving equations using factoring, and we talked about quadratic functions in Chapter 16. Chapter 18 is all about different methods for solving quadratic equations. A quadratic equation is an equation that can be written as ax squared plus bx plus c equals 0, where a, b, and c are constants and a is not 0. Just like we talked about in Chapter 14, if a equals 0, then we have a linear equation, and we would use different procedures for solving a linear equation than we would a quadratic equation. We've also talked about a graph of a quadratic function. The graph of a quadratic function is called a parabola, and the solutions of a quadratic equation, as far as the parabola is concerned, are the x-intercepts of the graph. When y is 0, we are finding the x-intercepts of a graph. We have 3 possibilities for x-intercepts for a parabola. There could be no x-intercepts. There are no x values that solve the equation. There could be one x-intercept, and that one x-intercept is also the vertex of the parabola. Or there could be 2 x-intercepts. Backing up for a moment to this no x-intercept graph, if we have no x-intercepts, that means our answers are complex numbers. We will see those in this chapter as we try to solve these quadratic equations. I'd like to remind you, before we move too far, about these x-intercepts and y-intercepts. A y-intercept is when x equals 0, and it tells us where the graph crosses the y-axis. To find a y-intercept, we would let x equal 0, plug it in to our equation, and solve for y. Or if we're using a function, we just plug in 0 for x. For an x-intercept, this is when y equals 0, and an x-intercept tells us where the graph crosses the x-axis. So going back to our 3 different situations here, recall from Chapter 14 that the highest exponent on our variable tells us how many solutions our equation would have. So a quadratic equation always has 2 solutions. In the situation on the right with 2 x-intercepts, these come as 2 different solutions, 2 different answers. In the instance of having only one x-intercept, the 2 solutions come, but they are equal, so we say this is one repeated solution. And in the case of no x-intercepts, we just finished talking about complex numbers. No x-intercepts mean we have 2 complex numbers. Let's take a look at a graph. We'll use our steps from the functions chapter to graph the function f of x equals x squared minus 6x plus 9. We'll sketch it on the grid to the right and give the coordinates of the vertex. So the first thing that we will do, I'll use the space on the left here because I have some space on the left. I need to find my vertex. So if you recall from the function chapter, to find the vertex of a quadratic function, we would first find the x-coordinate by saying negative b divided by 2 times a. So negative b over 2 times a. My b is negative 6, so I'll highlight my b here in yellow and my a in blue. b is negative 6, a is 1, and so I have 6 over 2, which is 3. My x-coordinate for my vertex is 3. I like to put my vertex in the middle on my table because of that symmetry of the parabola. To find the y-coordinate, we plug in 3 to the function. X squared minus 6x plus 9. X is 3, so I'll drop 3 in the parentheses. 3 squared is 9. 6 times 3 is 18. 9 minus 18 plus 9 will give us 0. That's an x-intercept because y equals 0. Then we can pick values around the vertex and plug those numbers in. If you recall, the numbers around the vertex should be equal because of the symmetry of the parabola. If I plug in 1 minus 6 plus 9, I get 10 minus 6, which is 4. That also means if I plug in 5, I should get 4. And we can test that out. 25 minus 30 plus 9, negative 5 plus 9 is also 4. Then you can plug in 2, x squared minus 6x plus 9. 4 minus 12 is negative 8. Negative 8 plus 9 is 1. And so if I plug in 4, I should also get 1. 16 plus 9 is 25. 25 minus 24 is 1. We can create our axes. For our parabola, 3, 0 will be 1 point on my parabola. 4, 1, 2, 1, 1, 4, and 5, 4. And our little grid marks are just going to be by 1s. Make sure you label at least 2 of them. I'm going to make this bigger. Label at least 2 of them on each axis so that someone reading your graph will know. And I'm going to cause my parabola to hit that x-axis a little bit better than it did. And there's our parabola. How many x-intercepts does it have? Right, it has 1 x-intercept, and it is the vertex of our parabola. Let's talk about solving it. If we needed to solve the equation, if we did not have the graph that we just created, we only have tools for solving this type of function right now using factoring. So let's try to factor. I have a trinomial. A is 1, B is negative 6, C is 9. I need two numbers that multiply to be 9 and add to be negative 6. 3 times 3 is 9, but I need them to add to be negative, so I'll take negative 3's. We can put that in here. Minus 3x plus 9. Factor by grouping. X minus 3, x minus 3. And we end up with x minus 3 times x minus 3 equals 0. We set each one of them equal to 0, but they are the same. When we solve this, we get 2 solutions. Both of them are 3. And notice the solution is also the x-intercept of the graph. And in this case only, the vertex.